In this video today, we'll be talking about Coulomb's law. So in this diagram, you have quantity 1, quantity 2, and quantity 3. They all have their own charges at the top and the distance in between each other. So a little information about charges is if the charges are the same, such as a positive charge and a positive charge, or a negative charge and a negative charge, the two would repel each other. However, if the charges are opposite, such as a positive and negative, the two charges would be attracted to each other. So for this example, we'll be focusing on quantity 1. So in order to draw the force diagram, we need to look at the difference between quantity 1 and quantity 2 first. So quantity 1 is a negative and quantity 2 is a negative, which means they're the same charge. So this would mean that they would repel each other. So to show that they repel each other, we would go the opposite direction of quantity 1. So we would go. So this would cause quantity 2 to go away from quantity 1. If we were to look at quantity 1 and quantity 3, they're a negative and a positive, which means they have opposite charges, so they're attracted to each other. So f of 3 would move towards quantity 1. So in order to use Coulomb's law, you need a formula. So the forces is equal to K times quantity 1 times quantity 2, divided by the distance between them squared. The K in the formula is equal to 9 times 10 to the 9th. So every time you use Coulomb's law, K would be equal to this. So to figure out the force on f of 2 acting on 1, it'd be K times the distance of 1, or the quantity of 1 times the quantity of 2 over the distance squared. So it'd be 9 times 10 to the 9th times 5 times 10 to the negative 6 times 3.2 times 10 to the negative 6 over 0.17 squared, which would give you a total force of 4.98. Once you find f of 2, you have to find f of 3 on 1. So you'd set it up the same, except the quantity of 2 would now be 3, so it would now be 7.4 times 10 to the negative 6 over 0.3 plus 1.7 squared, which would give you a charge of 1.51. The last step is you would need to find the net force, so you would take the charges from Q of 2 and Q of 1 minus Q of 3 and Q of 1, giving you a net force of 3.47. So that is how you do charges.